All right, the last thing I want to do, so kind of the last chapter for us to talk about in regards to R is chapter 16, which is about the analysis of variance test. So this uses the F distribution. So instead of using chi-squared or norm or T, you would use just F, just the letter F. So if you wanted to find a critical value, you would do QF and so on. And so remember that there's 2 degrees of freedom there. And again, I'm going to assume that you've watched all the videos, so you know exactly what those are. And you can, you have an F distribution table at your disposal if you want. It's on the handout, or you can just use R. I find it easier just to use R. So there we go. So the Anova test here, the analysis of variance, what I want to do is I want to do question 7 from the homework. This is one where you have we want to see how much of a difference the early evening or late night had at a speed that you could download files on a computer. So you can tell this question's probably a little bit old just based on the numbers, but it used to actually take some time to download stuff on the computer. Anyway, so you want to run an Anova test and see what's going to happen here and compute the test statistic. So I've already loaded the data here. So this is early is 61, 134, 94, and so on. The evening is 186, 301, and so on. And then the late night are the last columns. So I have those values already there. As far as the names go, I'm going to have early, evening, and late night. Okay, and so those are going to be the names that we have. So I put the quotes around them because they're actually just strings. They're characters. I don't want them to have values. They're just strings. They're literally just characters. And then I want to repeat these, each of them 6 times. So I want to repeat names 6 times. So I want to repeat the first one 6 times, the second one 6 times, the third one 6 times. And then I want to call that, I'm just going to call it rep names. And so that's each of those values repeated 6 times. Remember that this repeat function basically says that if I want to take the number, if I want to take A, B, C, and then I want to repeat the first one 3 times and the second one 7 times and the third one twice, that would be the code that you would use, because you get 3 A's, 7 B's, and 2 C's. Okay, so that's what the repeat function does. That's a very useful function. So if you want to have, say, 1, 2, 3, 4, and you want to repeat that 7 times. So if you don't put in a string with 7 characters, you just put in 7. Then this is going to say 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 7 times. If I were to put in an actual list, this would tell you how many times to repeat each number, right? So you repeat the 1 7 times, the 2 3 times, the 3 4 times, and so on. So anyways, that's the repeat function. So that's how I got the names to repeat. So the rep names get used there. And then once you have the rep names and the data, I like to take the data. So we remember we had early, evening, and late. So our data is just going to be early, evening, and late. We're just concatenating the data. And just to look at it there. And then one thing that's nice, but it's not really necessary for this, is you can take the data and the rep names and put them together and make what's called a data frame, just so that you can kind of look at the data in a nice way. So this is a nice representation of the table. So you have the early values are 61, 134, 94, and so on, and so on down the list. So again, not super important for what we're doing here, but that's it. And then to finish up this problem, we need to run one code, and it's in Anova on the analysis of variance. We're going to take our data, compare it to the rep names, and that's the Anova test. So the F statistic that we get is 14.074. Okay, so that's 14.074. What is wrong here? Oh, I'm not rounding. 14.07. And if you wanted to find the critical value, you could do the same thing here. So you would do QF. Here you would want to find the critical value for 5%. So that means you want to find up to which 95% happens. And then your degrees of freedom are 2 and 15. So remember, the degrees of freedom here is the number of categories minus 1, and then the number of data points minus the number of categories. So here it's 3 minus 1, and then 18 minus 3. And then that'll give you your critical value, and you want to round that to 2 decimal places. So that's going to be 3.68. And the critical value, again, you just interpret, and I'll leave that to you. But the test statistic lies beyond the critical value, and that's the end of it. Okay, so that's how you run the Anova test using R. There's not really many other variations that we need to worry about. There is one more homework problem here that uses, so not this one, but the last one. Notice that it has different sample sizes. Okay, so just kind of to point out the test, the way that I have the test set up, it's going to work regardless of whether your groups have different sample sizes or not. So with questions 7 and 8, you have sample sizes with the same number of points. So in question 7, for example, you have 3 groups, but they each have 6 data points. In question 8, you have 5 groups, but they each have 5 data points. And in question 9, you have 3 groups, but they have a variable number of data points. So the way that I have the function set up, it should handle that just fine. And that's really all there is to chapter 16.